Here I have a line on the coordinate plane and I want to know which two-variable linear equation corresponds accordingly with the line. Which one do you think is the right answer? You can pause the video here to answer the question. If you said all of them, you are correct. All of these equations are variations of each other. But how exactly did I get to that conclusion? Well, let's find out. Today, I will be exploring the properties of linear equations in two variables. More specifically, I will focus on the relationship between the three most common forms of linear equations. These three forms include the point-slope form, the slope-intercept form, and the standard form. The point-slope form is often used when we know the slope of a line and a specific point that resides on said line. To obtain the point-slope form, I will start with the slope definition. The slope, often denoted by the variable m, is defined by a change in y over a change in x, and it kind of essentially tells us how steep a line is. The general formula for slope is m is equal to y minus y sub 1 over x minus x sub 1. So, by definition of division, I can rewrite that as y minus y sub 1 is equal to m times the quantity x minus x sub 1. And this is with x sub 1 being a known x value and y sub 1 being a known y value. And there you have it, the point-slope form. I guess, in retrospect, the biggest takeaway from this section is that the point-slope form is merely a rewrite of the slope definition. Now, the slope-intercept form is a special case of the point-slope form, when the given point happens to be the y-intercept 0, b. If the given point is 0, b, then by definition of equal ordered pairs, x sub 1, y sub 1 is equal to 0, b, and x sub 1 is equal to 0 and y sub 1 is equal to b. Since this is the case, I can substitute those values into the point-slope form, which subsequently becomes y minus b is equal to m times the quantity x minus 0. I then use substitution again and replace x minus 0 with x, obtaining y minus b is equal to mx. Finally, utilizing transposition, I arrive at y is equal to mx plus b. Last but not least, we have the standard form, ax plus by is equal to c, which is equivalent to either the equation of a vertical line when b is equal to 0, or the slope-intercept form of a non-vertical line when b is not equal to 0. For the first case, if b is equal to 0, then a is not equal to 0. Plug in b and we get ax is equal to c. When simplified, we get x is equal to c over a constant. The graph of x is equal to c over a is a vertical line. If we compare that to the slope-intercept form, we have m, which is otherwise known as the slope, is equal to negative a over b, and little b, which is the y-intercept, is equal to c over b. Now, let's tie this back to our original question. I have a line with two known points 0, 1 and negative 1, 2. To find the point-slope form, I first find the slope by plugging in the values into the slope formula. I end up with 3. Then, since I only need one known point to plug into the point-slope form, I'll pick one of the two given points. My final answer is y minus 1 is equal to 3 times the quantity x minus 0. To convert this into the slope-intercept form, I will rewrite y minus 1 is equal to 3 times the quantity x minus 0 as y minus 1 is equal to 3x minus 0. Then I replace 3 times the quantity x minus 0 with 3x and move the terms accordingly. Eventually, I'll obtain y is equal to 3x plus 1. Finally, I will rearrange the terms to derive the standard form. I move the y and x values to one side of the equation, getting 3x minus y is equal to negative 1. I hope this video helped you understand the relationships between these three forms a little bit better. Thank you so much, and now go ace that test.